All right, in this video, I'm going to go over the questions from the B.E.S.T Algebra 1 EOC Sample Test available from the Florida testing site, flfast.org. I recommend that you go to the site and try the test yourself before watching this video. If you like my content, if you find it helpful, please like, share, and subscribe. All right, here we go. All right, let's start with number 1. Doug has 8 square pieces of wood. Each piece of wood has a side length of s centimeters. The total area of all 8 pieces of wood is 200 square centimeters. Create a quadratic equation Doug can use to find the side length of each piece of wood. Now, this question might sound like it's more difficult or complex than it actually is because they throw in the word quadratic. But remember, quadratic only means that our variable has an exponent of 2 on it, like x squared. And that makes sense if you think about what's going on here. We have 8 pieces of wood. Each piece of wood is a square. And so we know that in a square, all sides are equal. So if all 4 sides are the same length, then we could just say that each side measures s. So if you find the area of a square, you're doing s times s, or s squared. And if you have 8 of those squares, they're all the same, then you could just do 8 times s squared, and that gives you the area of all 8 square pieces of wood in one shot. Now, what do all 8 square pieces of wood equal in the area in one shot? 200 square centimeters. So our equation, our quadratic equation, is 8s squared equals 200. And so a reminder, when you see this keypad, that means a question on the actual test might require you to enter the equation using a keypad. Number 2, a band sells X premium tickets and Y regular tickets for a concert. A premium ticket costs $20. A regular ticket costs $5 less than a premium ticket. The band raises $2,145 from selling tickets. Select coefficients to complete the equation representing the relationship between X and Y. So we know that premium tickets are X and regular tickets are Y. Okay? So then all we're doing is adding the coefficients in front of X and Y to show the value of each ticket. So a premium ticket, which is X, costs $20. So this is going to be 20X. And on the test, this would be a drop down, and you would select a number from the drop down list. And a regular ticket costs $5 less than a premium ticket, which is $15. So we put here 15Y. So our equation is 20X plus 15Y equals 2,145. Moving on to number 3, enter an expression to make a true equation. XYZ squared minus 1 equals blank times XYZ minus 1. Now this may be difficult to recognize, but this is actually a difference of squares, which we write as A plus B times A minus B. And the answer to a difference of squares always looks like this. First term squared minus second term squared. Now, why does that happen? Well, let's say I have x plus 3 times x minus 3. When we FOIL, look at what happens. So x times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. And 3 times negative 3 is negative 9. Now look at the middle terms. Negative 3x and positive 3x, they cancel each other out. And we're left with x squared minus 9. So first term squared minus second term squared. And that's what we have here. XYZ in parentheses squared, that's a perfect square, minus 1, which is a perfect square in itself. So which part of the A plus B times A minus B do we need to put in here? Well, here, XYZ minus 1, we have the A minus B. All we need is the A plus B. So our answer is XYZ plus 1. Number 4, a function is shown. f of x equals 2x plus 1. Select all the effects on the graph of the function when f of x is multiplied by 3. So what that means here is we need to find the outputs of this function and then multiply them by 3 to compare what happens to the two functions. So let's make a table. So when f of x equals 2x plus 1, we know that the y-intercept is 1. If x is 1, 2 times 1 is 2, plus 1 is 3. And if x is 2, 2 times 2 is 4, plus 1 is 5. Now they're telling us to take each of these and multiply them by 3. So 1 times 3 is 3, 3 times 3 is 9, and 5 times 3 is 15. So what do we see here? Well, let's take a look at the y-intercept. It was 1, and it became 3. So here we have the y-intercept increases. Now, how about the slope? Well, the slope here was 2, but what is it now? Well, from 3 to 9, that's plus 6, and from 9 to 15, that's also plus 6. So the slope of 3f of x is 6. So the slope increases. And those are the correct answers. All right, number 5. The equation for the function f is shown. F of x equals negative half x plus 3. The quadratic function g has the following properties. G has a lesser y-intercept than f. The maximum value and y-intercept of g are not equal. First g increases and then it decreases. Drag the vertex and the y-intercept labels to show possible locations for the vertex and the y-intercept of g. So on the computer, you would actually click and drag each of these points to place them where they go to meet all of these requirements. First, since we're going to compare the y-intercept of g with the y-intercept of f, let's go ahead and put a point on positive 3 so that we have a reference point for the y-intercept of f. Now it says g has a lesser y-intercept than f. So that means we could take this y-intercept point and drag it and place it on the y-axis anywhere under positive 3. Anywhere that we put it here will be fine. Let's put it at negative 2. And that's where our y-intercept is. Now it says the maximum value and y-intercept of g are not equal. So this tells us something, because when we talk about quadratic functions, the graph of a quadratic function, the quadratic function, the graph is a parabola that either opens upward or it opens downward. Now, when a parabola opens upward, the vertex is the lowest point on the graph because it has the lowest y value, and it's recognized as the minimum value. When a parabola opens downward, the vertex is the highest point on the graph because its y value is the highest y value, and it's recognized as the maximum. So here, when they say the maximum value, they're telling us that we have a parabola that opens downward, like this one. And that makes sense if you look at the third point. First, g increases, then it decreases. When we look at this parabola that opens downward, and we read it from left to right, it increases, then it decreases. So our maximum value, our vertex, and our y-intercept are not equal. What does that tell us? That tells us that we can place our vertex anywhere on this graph except for on negative 2. So let's go ahead and put it right out here. This works. This is our vertex. All right. So this parabola might look something like this. I know it's very ugly, but you get the point. The y-intercept is less than the y-intercept of f, and the vertex and the y-intercept are not equal, and this vertex is a maximum, and this graph does increase and then decrease. Number 6 says the expression 15,000 times the quantity of 1 plus 0.02 to the m power can be used to model the sales in dollars of a company after m months. The value 12 was substituted for m to create the expression 15,000 times the quantity of 1 plus 0.02 to the 12th power. Enter a number and select a unit to complete the sentence. The expression 1 plus 0.02 to the 12th power represents the growth factor of the company's sales for a period of time lasting. And so we have to enter a number and select a unit of time from the drop-down list. So the key is in the fact that m represents months. So how much time is 12 months? 1 year. So we could put 1 and select year from the drop-down. But we could also enter 12 and select months from the drop-down. And we could even enter 365 and select days from the drop-down, or what if it's a leap year? We could enter 366 and select days from the drop-down, and all of those answers would be correct. Number 7, a table of values for a linear function is shown. Match each key feature of the graph to its value. So first is x-intercept. Look at the table. Do we have the x-intercept? Yes, we do. It's right here. Remember that the x-intercept is the value of x when y is 0. So our x-intercept is 3. The y-intercept, do we have it here? No. Let's move on to the rate of change. We can figure that out. In x, from -1 to 3 is +4, and from 3 to 6 is +3. For f of x, from -8 to 0 is +8, and from 0 to 6 is +6. And so rate of change is change in y, or f of x, over x. So that's going to be 8 over 4 and 6 over 3, and they both equal 2. So our rate of change is 2. Now we can use this rate of change to find the y-intercept. Remember that our equation is y equals mx plus b, and we know m is 2. So we write y equals 2x plus b. Then we just need to pick one of these points and substitute for x and y, and then solve for b, which is our y-intercept. So let's take 6, 6. So 6 equals 2 times 6 plus b. 2 times 6 is 12. And when we subtract 12 from both sides, we get b equals -6. So our equation is y equals 2x minus 6. So our y-intercept is -6. Number 8, the fuel economy of a car is its average distance traveled per amount of fuel consumed. Cars have different fuel economies when they are driven in the city and on the highway. A linear model of the relationship between the city and highway fuel economies of 8 cars in miles per gallon is shown. This question has 2 parts. Part A, which linear equation best models the scatter plot? So the easiest way to really do this is to pick some points on the graph and plug them into the different equations and see which ones give you a good line that runs through these points well. In order to save time, I'm just going to go straight to the correct answer, which is A, and show you how that works. So I'm going to go ahead and pick, since my slope is 2/3, I'm going to pick numbers that are divisible by 3. So I'm going to pick 30 as my x value, and let's work this out. So we have y equals 2/3 times 30 plus 19. 30 divided by 3 is 10, times 2 is 20, and 20 plus 19 is 39. So when x is 30, y is 39, and that's going to be this point right here. So then let's go ahead and pick 39 for x. So y equals 2/3 times 39 plus 19. 39 divided by 3 is 13, times 2 is 26, and 26 plus 19 is 45. So when x is 39, y is 45, and that's right here. And then we can go ahead and sketch our line. And we can see that that makes a pretty good line of fit for this scatter plot. Part B, based on the model in Part A, what could be the highway fuel economy in miles per gallon of a car that has a city fuel economy of 43 miles per gallon? Round your answer to the nearest hundredth. So we're going to use the same equation that we used from Part A, which is y equals 2/3 x plus 19. And then we're going to plug in this 43. So 2/3 times 43 plus 19. 2/3 times 43 is 28.6 repeating. So let's call that 28.67. And 28.67 plus 19 is 47.67. So that is our answer. Number 9. This question has 2 parts. Giselle has 40 prizes for raffle ticket winners. She gives away 2 prizes each day until she runs out of prizes. The equation P plus 2T equals 40 represents the situation where P is the number of prizes Giselle has left after T days. Part A, first select P or T to represent the independent variable. Then use the add arrow tool to graph the relationship. So let's say we decide that T is our independent variable. So when you click on T here, it's going to put T down here and P here. Now we got to plot our points, right? So we can use the X and the Y intercepts. So if we say P plus 2T equals 40, and we make P 0, then we get 2T equals 40. We divide by 2, and we get T equals 20. So we come down to T, and we put a point on 20. Then we're going to do the same thing. Now we're going to make T 0. So when T is 0, 2 times 0 is 0. So this goes away, and we end up with P equals 40. So we go to our P-axis, and we put a point on 40, and then we graph our line. So that's part A. Part B says enter a value in each box to describe the relationship. The domain of the relationship is from blank to blank. All right? So domain, remember, is the list of the inputs. So if we look here, the domain of the relationship is from 0 to 20, because those are the inputs. And Giselle will give away all the prizes after how many days? So if P, this is the number of prizes, after 20 days, we will be at 0 prizes. And so that's the answer. Now, had we selected P as our input, then the P would be down here, and the T would be here. These numbers would still be the same. So we would still have T equals 20, and we would still have P equals 40. And now our graph would look like this. Now when it says the domain of the relationship, now that's P. And P goes from 0 to 40. But this part, and Giselle will give away all the prizes after blank days, is the same, but we're going to look this way. When is P 0? When T is at 20. So this part is still 20. All right, number 10. A school office surveys 6th and 7th grade students about whether they ride the bus to school. The data are recorded in a frequency table. Enter numbers to complete the frequency table for the data. So all we're doing is using a combination of addition and subtraction to fill in the missing parts. So here we can find a total for 6th graders by adding together the 176 that ride the bus with the 74 that don't ride the bus, and we get 250 in total. Here, for our total number of students, 400 total students, 250 are 6th graders, so 400 minus 250 is 150. We could also look at do not ride the bus. 74 are 6th grade, and it's a total of 128. So we do 128 minus 74, and we get 54. So for 7th graders, we have 150 total 7th graders, and 54 of them do not ride the bus. 150 minus 54 is 96. And then for our total of students who do ride the bus, 176 6th graders plus 96 7th graders, that equals 272 total students who ride the bus. Number 11, a system of inequalities is shown. Inequality number 1, y is less than negative x minus 1. Inequality number 2, y is greater than or equal to x plus 1. A, select a solid or dotted boundary line for each inequality. B, click in a region to graph the solution set of the system. So here you would be clicking to select which kind of line you have and then placing it. So for inequality 1, we see that it is y is less than. It's not an or equal to. So for inequality 1, you would be clicking on the dotted line. Now let's go ahead and graph that. Our y-intercept is negative 1. So that goes right here. And our slope is negative 1. That means we're going down 1, right 1. So down 1, right 1, down 1, right 1. Here we go. And I'm placing all of these points because since it's not or equal to, it is a dashed or dotted line. And so here it is. Now, it is y is less than. So for this line, less than is on the left. So let's do this. Now let's do inequality number 2. Inequality number 2 is an or equal to, so that's going to be a solid line. So we would click here. Now our y-intercept is positive 1, and our slope is positive 1. So that means we're going to go up 1, right 1. So we can do that. And this line is solid. So we can just go ahead and draw it all the way through. And the shading is greater than on this line. Greater than is above it, which is to the left. So we're going to shade all of this. Now the solution set, the area that you would end up clicking on is the area where the two shadings overlap, which would be this area here. All right, number 12. The table shown represents two functions, function A and function B. Complete the sentences to compare the two functions. So function A, let's take a look at this one and compare the rate of change. For x, here we have plus 1, here we have plus 9, and here we have plus 10. For the y, the output of function A, here we have plus 50, here we have plus 450, and here we have plus 500. So if we make our rate of change, our slope, change in y over change in x, we have 50 over 1, that equals 50, 450 over 9, that equals 50, and 500 over 10, that equals 50. So this is a constant rate of change. That means this is a linear function. So function A appears to grow linearly, and you would select this from a drop-down list. Now, how about function B? So if we take a look at function B, the change here for function B is plus 24, plus 264, and plus 427. And when we make these fractions, 24 over 1 equals 24, 264 over 9 equals 29, and 427 over 10 is 42.7. And if we were to look at the second differences, from 24 to 29, that's plus 5, and from 29 to 42.7, that's not plus 5. So this is not a quadratic function, this is an exponential function. So function B appears to grow exponentially. As x increases, the quantities for blank will eventually exceed the quantities for blank. Now, remember, this is an exponential growth. The numbers are getting bigger. So this is going to go up like this, but function B is going to go up like this. So eventually, since function B is exponential, it will surpass function A. So as x increases, the quantities for blank will eventually exceed the quantities for blank. So the quantities for function B will eventually exceed the quantities for function A. Number 13, in a survey of 3,260 people, 57% of people said they spend more than 2 hours a day on their smartphones. The margin of error is plus or minus 2.2%. The survey is used to estimate the number of people in a town of 17,247 who spend more than 2 hours a day on their smartphones. Based on the survey, what are the estimated minimum and maximum numbers of people in the town who spend more than 2 hours a day on their smartphones? Round your answers to the nearest whole numbers. So this is margin of error, and all we're doing is adding and subtracting this percent to the 57%. So 57% minus 2.2% is 54.8%. And 57% plus 2.2% is 59.2%. Then all we're going to do is really find these percents of this number. So when we do 17,247 times 54.8% as a decimal, that's 0.548, we get 9,451.356. So if we round this to the nearest whole number, that's 9,451. That's the minimum number of people in this town who spend more than 2 hours a day on their smartphones. And then when we do 17,247 times 0.592, we get 10,210.224, which rounds to 10,210, which is our maximum number of people in this town who spend more than 2 hours a day on their smartphones. All right, last question, number 14. An expression is given where x is not equal to 0. Richard divides incorrectly to get the given quotient. Click on the incorrect parts of Richard's quotient. So let's just go ahead and divide this correctly then. So we have 2x to the 7th divided by 2x. 2 divided by 2 is 1, which we don't need to write. And x to the 7th divided by x to the 1st. When we divide powers that have the same base, we subtract the exponent. So 7 minus 1 is 6. So that is x to the 6th power. Next, 8x to the 4th divided by 2x. 8 divided by 2 is 4. And x to the 4th divided by x to the 1st is x to the 3rd. Finally, negative 14x divided by 2x. Negative 14 divided by 2 is negative 7. And x divided by x is 1. So there's no x here. It's a 1, and negative 7 times 1 is negative 7. So that stays like that. So looking at Richard's quotient, what mistakes did he make? Looking at the first term, he has a 2 when there shouldn't be a 2. So you would click on the 2. In the middle, 4x to the 3rd, 4x to the 3rd, that's correct. On the end, it should just be a negative 7, and he has negative 7x to the 1st power. So you would click on the x to the 1st power. All right, I hope you found this video helpful in getting you ready for the EOC. If you have, please like, share, and subscribe.